Greetings and welcome to my new calculus channel. My name is John Gabriel. So I've been talking a lot about mainstream stupidity and differentiation, integration, and calculus in general, and how it is very incorrectly formulated and has been and has never been rigorous. So in this next video, I want to talk about three calculus concepts that mainstream mathematics academics know nothing about. They're continuity, tangent line, and smoothness. Okay, so let's look at continuity first. Paul's online notes state a function f of x is said to be continuous at x is equal to a if the limit of f of x as x approaches a is equal to f of a, and it's continuous on the interval if it's continuous at every point in the interval. Okay, now that's a garbage definition, and here is the geometric definition, which I've given to you in green. Okay. A function is continuous at a point x in f if there is a path that includes x and has no disjoint parts. And I explained that to you previously, okay? So if we have a function like this, something like this, we say that it is continuous over this integral if there is no part, if there is no disjoint part, okay? No disjoint part, then it's continuous. Right. So, and over an interval, it's continuous on the interval if there are no disjoint parts of f in that interval. Okay, so it's continuous at a point if there is a path that includes x and has no disjoint parts, and over the interval if at all points of the interval. Now, there is nothing that makes limit of fx as x approaches a equal to fa more rigorous than the above geometric definition. Nothing, either at a point or over an interval. Are you listening, Zealous Malem and Marcus Cliver? Symbols do not make mathematics more formal or rigorous. I love making fun of this idiot pair. It's just irresistible. Okay, the next thing we look at is the concept of tangent. Again, here, mainstream mathematics academics don't even have a valid definition of tangent line. Let's take a look at what one well-known site says. So on Paul's online notes, he says, a tangent line to the function f of x at the point x is equal to a is a line that just touches the graph of the function at the point in question and is parallel, and in parentheses, note what he says, yeah, in some way. It's either parallel or it isn't parallel, okay? And it says, take a look at the graph below. So it says you've got a tangent line at this point, but not over here. And what follows is really hilarious. He says, in this graph, the line is a tangent line at the indicated point because it just touches a graph and is also parallel, in quotes, to the graph at that point, okay? Likewise, at the second point shown, the line does just touch the graph at the point, but it is not parallel to the graph at that point. And so it's not a tangent line. Well, I don't know. There is, if you understood what that means, well, there's something wrong with your brain because that's nonsense that can't be understood, okay? So, and then he says at the second point shown, the point where the line is not a tangent line, we will sometimes call the line a secant line. And then it says, very, very telling, we've used the word parallel a couple of times now, and we should probably be a little careful with it. In general, we will think of a line and a graph as being parallel at a point if they are moving in the same, what? Moving in the same direction at that point. Well, I don't see either the line or the graph moving anywhere. They're static. So I don't know what he's talking about. So in the first point above the graph and the line are moving in the same direction, and so we will say parallel at that point. I don't know how he works out that they're moving in the same direction. That blows my mind. I mean, first of all, they're not moving, and if they were moving, it would be impossible to determine what the direction is. So at the second point, on the other hand, he says the line and the graph are not moving in the same direction, so they aren't parallel at that point. That's really absurd. Okay, so Then finally, in the next part of it, and you can check out the link here, Paul says, okay, now that we've gotten the definition of a tangent line out of the way, let's move on to the tangent line problem. Poor students, they get into debt for hundreds of thousands of dollars to memorize crap like this, okay? And note how Paul claims a line that just touches the graph of the function at the point in question and is parallel to the graph at that point. Parallel in some way, never heard of that. I mean, it's either parallel or it's not. So, also very telling is the way he says we've used the word parallel a couple of times, and we should probably be more careful. So, it's impossible to define direction in any rational way in this case. The lecturer is delusional, just like all his mainstream colleagues. This garbage was started by that fool Leibniz, who peddled the idea that a tangent was almost equal to the straight part of the graph, to the straight part of the curved graph. Isn't that absurd? Of course it is. So, according to Paul's definition, a tangent line is not possible at points of inflection because there is no parallel line there. Guess what? This is verified by my 100% new calculus formulation. And I'll explain that in a moment. So he says, Paul says, because there is no parallel line there, and its both directions are different. Paul is obviously an idiot. Okay, so let's quickly look at what's happening here. So if we've got a graph like this, there is a point of inflection here, by the way, right here at x is equal to 3. And in the new calculus, we find the derivative by parallel secant line. So watch what happens here. There isn't any line that's parallel there to the tangent line. Okay, no line. I mean, unless you consider the tangent line as being the line that is parallel to itself, which is kind of stupid because a line can't really be parallel to itself, right? It's usually parallel in reference to another line. Okay, so that's a garbage mainstream concept. And then, of course, what is really strange is that it's impossible to determine direction here. So, what direction is the line going there? Even if there is a tangent line, is it going left, right? Where is it going? Maybe some subatomic space there or something? I don't know. I mean, mainstream calculus lecturers are such morons and so incorrigibly stupid that you cannot reason with these people. Okay, so let's see now geometrically what is the definition of a tangent line. Okay, very simple. A given straight line is tangent to a function f at x if the tangent line meets at x, extends to both sides of x, and never crosses at x. Okay, that is a geometric definition. Let's move over to smoothness. So Paul doesn't have a definition for smoothness. He simply calls, or he simply implies smoothness of f over an interval if f is differentiable at every point in a given interval. So to be differentiable means to have a tangent line at every point in the interval, right? Only problem is that the mainstream morons have no formal definition of tangent line. I mean, we saw how he failed brutally at defining a tangent line. I mean, he talked about parallelism and direction and lots of other crap. Okay, so there have been many attempts, but every one of them are circular because the derivative is the slope of a tangent line. And in order to determine that derivative, one must first know what the hell the tangent line is. Okay, let's give a proper definition of smoothness. Geometrically again, a function f is smooth over this interval if only one tangent line is possible at every point in this interval, with the exception of inflection points, okay? So it doesn't matter that there's no tangent line there. It's still smooth in this, let's say in this interval 2.5 to 4, and actually it's smooth everywhere, in fact. But that just goes to show you that mainstream academics have no clue what calculus is all about. They've never understood calculus. It's just a haze of abstruse concepts vague notions that they've had. They don't understand these things, okay? And they never will, because a crank can't be turned, all right? So they are collectively idiots, and all their colleagues are also in the same category. Their obtuseness has no limit, okay? Their stupidity has no limit. And excuse the pun, because they love the word limit and limit theory. So they cannot be corrected because cranks cannot be convinced, even in the face of overwhelming evidence. All right, then. If you're not already a member of my channel, I mean a subscriber, become a subscriber. Follow me on academia.edu, and I'll place a link to all those. Also, you can become a members only participant for a mere €4.99 a month. All you have to do is just click join on any one of my videos, and you're good to go. I'm John Gabriel, and this is a new calculus channel.